here is a very basic related rate problem. Changing temperature. C is the temperature in Celsius. T represents the time in minutes. We place a bottle of soda in a refrigerator. So the temperature of this soda can be described by the function C of t equals to 5 plus 14 times e raised to the negative 0.0t. My question is, how fast is the temperature changing initially? So you see the word changing in calculus. Changing means rate of change. So when you hear the word rate of change, you will have to take the derivative. So for the derivative, most people will just do a c prime of t, right? But in a related rate problem, I highly recommend you to just write dc dt instead of c prime of t. You will see why when you get to a more deeper problem. So the derivative of 5 is equals to 0, and then we have a chain rule plus 14 e to the 0.02t, and then the derivative of the exponent is equals to negative 0.02. So the derivative is done, and then now we are going to answer the questions. They said initially. So what is initially mean? Initially means the time is equals to 0. So let's follow the color code initially. That means time is equals to 0. So the rate of change of temperature is equals to 0 plus 14 e to the negative 0.02 times 0. So that makes the exponential term equals to 1. And then you multiply negative 0.02. So basically you have a 14 times negative 0.02. That is equals to negative 0.28. Be sure to write the unit. That is Celsius per minute. This is very important. This is negative. What does that mean? Can the Celsius be negative? Yes. Can the minute be negative? No. But how about the rate? When the rate is negative, that means the temperature is decreasing, which makes sense. You put a bottle of soda in a refrigerator. So of course the temperature is decreasing. And then how about after 8 minutes? So 8 minutes later, let's follow the color code as well. So 8 minutes later, okay, change that to a blue. So after 8 minutes, what happened? You have to plug in 8 to the time, right? So that means t is equals to 8. So t is equals to 8. Then dc dt is equals to 0.14 e to the negative 0.02 times 8 times negative 0.02. So that gives you approximately. So this time you have to approximate, because that one when t is equals to 0, we have a 1. Approximately equals to negative 0.24. The unit is Celsius per minute. So this is also negative. That means the temperature is decreasing, but decreasing at a little bit slower way compared to the initial time when after 8 minutes. So 8 minutes later is decreasing at 0.24 Celsius per minute, but initially it was negative 0.28 Celsius per minute. All right, so that is the end of this problem. If you like the way I explain related rate, give me a like, share, and subscribe. Highly appreciate your help, and I will see you all in the next related rate problem. Signing out.